So at the start of the question, we read it, and we made sure to understand a few things. That h was height in this equation, that t was time in this equation. We then also drew a picture to kind of model somebody hitting a baseball, right? When they hit a baseball, it goes up, it goes down. It creates a parabola, right? So that's where these word problems are. You should be creating parabolas. And those parabolas you can graph to solve all the questions that it's asking. The first question was, what is the maximum height reached by the ball? If you're looking at your picture, this right here would be the spot where it's highest. So that's the spot you should be looking for. We then set an appropriate window before we actually graph this thing. So we put it into our calculator, 3 plus 48x minus 16t squared. And then we did talk about our window. Our window, we set x minimum at 0, because that makes sense. It's the least amount of time that could go by. Our x max, we put 15, because we felt that was for sure a reasonable amount of time for a ball to be in the air. 15 would be a pretty good maximum amount. We then did our y minimum at 0, because y is height, and a 0 height would make sense for a ball. You're not going to have less than that. And then we did y maximum height, and we understood that height was in terms of feet, which was important, because that just helps you decide what your y max should be. If this had been kilometers, that's much different than measuring in feet. If it had been in inches, that's much different than being in feet. We set a maximum height for a ball in feet. We felt 50 was pretty high. And we understand that this window is not an exact science, and it's probably not perfect. But what it should do is give us enough info when we graph it to then make a window that does work. If this one doesn't. We hit graph. We see, oh, I didn't fix my window, so we don't see anything. So I fixed my window. And what we end up seeing is a very small quadratic. So if I follow that window, my quadratic looks like this. And that, like, technically that works, right? Like, we can see what we want to see. But we have a whole bunch of wasted space in this portion of the graph. That tells me that our x maximum was significantly too high. So we can lower that x maximum quite a bit and tuck that in. You don't have to. I'm going to, because it gives you just a better picture of what's going on. So I would change my x max to be 5 instead of 15. And then all of a sudden you have a quadratic that you can really assess and you can really look at. So my quadratic now looks like this. By changing my x maximum to be 5. You just have a better vision of what's going on. All right, from this moment forward, we can start answering questions. Question A said, what is the maximum height? To find maximums in your calculator, you go second, trace, and you find the word maximum. It's right there for you. So you go down to number 4, find maximum. It says left bound. You choose a point that's left of your maximum, somewhere over here where I'm pointing with my fingers. I go all the way over there, I hit enter. Then it says right bound. I move my cursor to the right, somewhere over here. It says guess. You don't want to guess. You hit enter one more time. And it tells you that this point is at 1.5, comma 39. The question was, what is the maximum height? You found the point that's the maximum on your parabola. But you need to know what x and y mean. X was your time. Y was your height. So that means at 1.5 seconds, they have a maximum height of 39 feet. The maximum height is 39. Understanding what your x and your y mean is huge, especially when we did those profit questions in Unit 3. Understanding that x isn't price or anything like that was very vital. Question B. After what time does it reach the maximum height? 1.5 seconds. That's what the x value is telling you. It's telling you that after 1.5 seconds, the ball reaches a maximum height of 39. All right, part C. This is the question that throws a lot of people off because it doesn't feel like it gives much info. You could see this question written two ways. The first way you could see written is, how long was the ball in the air? They could just stop right there. That means you're looking for when it hits the ground. How long till it hits the ground, which would be your x-intercept. In this case, though, they switch it a little bit. They say, how long was the ball in the air if the catcher catches the ball 3 feet above the ground? So the ball actually never reaches the ground. If we're looking at our picture, the ball gets caught like right there. So you can't look for your x-intercept. You have to somehow look for this thing right here. That's exactly what you're going to do. So at this point, you want to figure out how long. So you're looking for an x value. You know that your y value is at 3. Your calculator does not know how to insert y values. What your calculator can do, though, is it can draw a line right there. It can draw a line at y equals 3. And then it can figure out where your two lines cross each other. So in your y2, you're going to put y2 equals 3. And you're going to get an extra line on your graph, like I do right there. It runs right across the bottom of my graph. Your calculator can figure out where they cross each other, which would be the point that we're actually looking for. You go second, trace, intersect, the 5th option. So intersect tells you where two things cross each other. So when it says first curve, which it will, it's asking you, because you could graph, remember, like 10 lines on your calculator. So it wants to know which lines are you actually looking for that cross each other. It brought me onto my parabola as my first option. I move my cursor so that it's close to where the intersection is, and I hit enter. Then it's going to say second curve, and it should have moved your cursor to the second line, and it should have automatically put it pretty close to where they cross each other. That's because it's kind of guessing where you're trying to look. You hit enter again, it says guess, you hit enter one more time, and it tells you that this point is at 3, 3. That means after 3 seconds, the catcher caught it 3 feet above the ground. So the answer would have been 3 seconds. Well, it means the catcher just didn't get it.
Can you just look at this? Because I don't know how to make it. Like, it keeps covering the thing.
And I'm running into the same problem as well. So you might be running into an issue where you can't see the intersection point, right? When you go second trace intersect, because the words come up right on top of your stuff. So if that happens, what you need to do is just make your window a little bit bigger. So take your y minimum and make it like -3. And that'll lower it a little bit and give you a little bit of space to work with. And then you should be able to see where your actual thing is when the writing comes up.
Okay, and then where?
Okay. What is the domain and range of this situation? Now, up until this point, we've always just said a domain is XCR, range is y is less than or greater than. This is going to be a little different this time. The reason it's a little different is it's asking about this situation, where somebody hits a ball and it gets caught 3 feet above the ground.
How do you know if that's that situation? Because it's just
Yeah, I guess we could reword it to say the situation in part C, and then that would make it a little more clear. Yeah. Typically, part C is just like the ball hits the ground, so you would assume whenever it hits the ground. But since they strictly said it got caught, we just follow off that. But you're right, it should say situation in part C to make it more clear. We're going to start with domain. So domain is possible x values. The x values in this case were time. So we want to set up our possible values for time. What's the least amount of time that could have passed in this situation? 0. And we know that x is going to be bigger than that. And so we go to 0, has to be less than x. Then there's a maximum amount of time that this ball could have been in the air before it got caught. How long did it take for the ball to get caught again? 3 seconds. So x has to be less than 3. And that's how we would write the domain. X is greater than 0 amount of seconds, but it's less than 3 seconds. And it could be anywhere in between, including equaling those two values. So it could have been 0 seconds, hit the ball, you could stop the ball at any point in time, all the way up until 3 seconds. Anything beyond that doesn't make sense. Domain. The domain's a little bit tricky. So, what's the least amount of time that this ball could have been in the air? We have to check 2 things here. Because we know that the lowest point on this side of the parabola was when he caught it. But there is potential that he hit the ball at a lower height at the beginning. It's possible that he hit the ball at, like, say, 2 feet, right? If he hit it really low. Or maybe he hit it, like, right off the ground. Maybe, like, it was a golf swing, and he hit it way down at, like, 1 feet off the ground. So you have to figure out the lowest point. Do we know when the y-intercept, when he hit the ball? Is there a quick way to find out what it is?
3.
How do you know it's 3? Because it's in general form and it's your c value. So 3 is actually your y-intercept, and it's when he catches the ball. So the lowest height this ball ever hits is 3 feet.
They also say, like, it's, this thing where it hit the ball, it says, like, 3 feet tall, and you do someone else is 3 feet tall.
Yeah,
That would work at the same time.
that would work, yeah. So if he did it from 3 feet, that would, and it said that would work. Yeah. So you have to use a little bit of intuition to figure out, okay, the lowest part could have been over here, or it could have been over there. Then you do your symbols. So 3 had to be less than or equal to y. So the height is always going to be greater than that. And the height of the ball will never get bigger than 39. Right? That was the maximum height the ball ever reached. So this range says the height of the ball has to be between 3 feet and 39 feet at all times. And then, yeah, you could throw in XER, Y. Just saying that it could be any number in between there. Questions like that, that's what we did a lot of in Unit 2. You remember. Alright, something else we learned. There's a bit of Unit 2, bit of Unit 3, was something called a discriminant. And the discriminant was something that you found underneath the root sign in your quadratic formula. So the discriminant was b squared minus 4ac. It's this thing right here. And the discriminant can help you figure out how many x-intercepts you're going to have. The reason why it'll do that. The quadratic formula calculates x-intercepts. If you have a discriminant that's negative, then the quadratic formula won't work, right? Because you're square rooting a negative number. If the quadratic formula doesn't work, that means you have no x-intercepts. It's not possible. If your discriminant equaled 1, that means that you would have plus or minus the square root of 1. Sorry, I said 1, I didn't say 0. If your discriminant was equal to 0, that means you have plus or minus the square root of 0. What's the square root of 0 always equal to? 0. What's anything plus 0? Still the same thing. What's anything minus 0? Still the same thing. Adding or subtracting 0 makes no difference in your numerator. Meaning that if your denominator equaled 0, discriminant equals 0, you have one x-intercept. If your discriminant was any other number, anything above 0, you're always going to get 2 answers. Because you have the positive version with the plus symbol, and then you would have the negative version, the minus. So that's how the discriminant works. And we can look at it pictorially as well with graphs. So if we're looking at this question, it says determine a possible value of the discriminant. I'm going to label these A, B, and C. For the quadratic equation that corresponds with the functions below. For A, a possible discriminant for A, there's only one answer. There's only one x-intercept. That means the discriminant must equal 0. One x-intercept, discriminant must equal 0. You look at number B. You look at letter B. There's 2 x-intercepts. So they want a possible discriminant. There's like an infinite number of discriminants that could create this situation. So if you answered anything where the discriminant is greater than 0, you would be right. So you could say 0.5, you could say 1 million. You could say anything in between. And you would be correct. If you look at C, you notice that there's no x-intercept. If there's no x-intercept, there's an infinite number of possible discriminants. But they all have to be numbers that are less than 0, that are negative, because that gives you no solution. We did this, and you should probably remember the slide with the little chart, and we did it like 3 or 4 times, where we talked about the discriminant and what it does. It creates 1 solution, 2 solutions, or 0 solutions. We then had questions like this, which were much more challenging with the use of the discriminant. So this is where they give you a quadratic, but in that quadratic, you don't know your A, B, or C value. In this case, you don't know your A or your B value. So it's going to make things a little bit difficult. It says, for what value of K is there 1 solution? When you read 1 solution, that has to be important to you. What does that mean about the discriminant, Jax? It means that the discriminant must equal 0. That means B squared minus 4AC must equal 0. It has to, if you want 1 solution. That's the key. And if they said 2 solutions, you would have a greater than symbol. If it was 0 solutions, you'd have a less than symbol. Right? But those words, 1 solution, no solution, 2 solutions, those words are really important to be able to do these questions. And understanding that's your hint to the question. The actual calculation of it also throws people off. Because then they look at this and they go, well, we don't know what K is. And that's exactly right. You don't know what K is. You're trying to calculate it. So follow this discriminant formula and label these things as A, B, and C. This entire thing is B. So if I was to put this in my formula, B squared, I would put K plus 4 squared. And then minus 4 times A, which is K, times C, which is negative 0.5. So you have to recognize that if you put all those values into your discriminant, you'll be left with 1 equation with 1 variable. You're left with only K's. And now you can solve a quadratic to figure out what K has to be. This is a good question because it makes you understand what a discriminant does. Also makes you understand how to solve quadratics. That's why you see questions like this pop up. It hits both sides. Does anybody have any questions about how I got to that point? Because it's about to get a little crazier. Yeah.
So, either K plus 4, so is that just mean like X plus 4?
Like K plus 4.
Yeah.
That means B equals K plus 4. Solving this is going to be another problem. And I'll get to solving it, yeah. But I just want to make sure everyone's got the right things plugged in and they understand where I got things from. Because solving it is a little tricky, and that's going to pose a problem. We're good? All right. If you get to this point, you're trying to solve an equation. The first thing is knowing what type of equation you have. This is going to be a quadratic because I have a variable and I have a squared in there, so it's a pretty good chance it's quadratic. What form do you have to be in to solve a quadratic? General form. So your first step is expanding this thing into general form. When you expand it, this does not become k squared plus 16. A binomial squared means there's two binomials there. So it changes to k squared plus 8k plus 16. So remember to actually expand that properly. Do an area diagram or do FOIL, whichever one you prefer. Over here, recognize that these are all coefficients. These things are all multiplied together. So if you go -4 times -0.5, you'll get plus 2k equals 0. Yeah, in a second. I'm going to make sure people are with me, because that usually loses people. So this part that I put in red, remember this is multiplication. This is -4 times k times -0.5. So multiplication can be done in any order, right? If you have two coefficients that are numbers, you can combine them by multiplying them to become plus 2. Two negatives become a positive. 4 times 0.5 becomes 2. And then the k just remains because it can't multiply by anything. Because this isn't a minus, this is a subtraction. Or sorry, this is a negative.
Yeah.
Would you still get to this point?
Like,
That's what I'm doing. If you can expand that and get positive 2k and you're doing it a different way, that's all right too.
I don't think I would though.
I think the important thing is realizing that the k and the -0.5 are separated. They're not in one set of brackets. It's not k minus 0.5. It's k and then it's -0.5. So it's like having a whole bunch of things multiplied. It's like having this. It's like having 2 times x times 3. You would just multiply the coefficients together to become 6x. It's the same type of situation. That part always loses people. It's like that spot in vertex form where people add the two numbers together when they're not supposed to.
I just don't get why you don't expand. Make it -4 goes to the k, and then -4 goes to the -0.5. They're all times in together.
That would be like this. That would be if it went like this. Or this k is. That's when you would expand it. But because this isn't a binomial, it's two monomials. That's why there's the brackets around. That's why you can't expand. Alright, at this point, now you can collect like terms. So you have 8k plus 2k, so you have k squared plus 10k plus 16 equals 0. And now you're free to solve that quadratic any method you want. You could graph it and find the x-intercepts. You could use quad formula. You could use box method. You could use factor. I would factor this thing. So if you factor it, it's 16, 10, 8, and 2. That gives me k plus 8, k plus 2 equals 0. That means the two values of k that would give you one solution would be k equals -8 and k equals -2. Both of those would give you one solution. Both of those would give you a discriminant equal to 0. That's a hard question. It's also something that has been tested a lot. Usually when something gets tested a lot, there should be a warning to you that it's probably going to get tested again on a final exam or a midterm. Maybe both. And usually when you see something pop up a whole bunch of times, that's a hint. And it's coming. Yeah.
So if it said like it wanted two solutions, would you change the 0 to the 2?
Yes. So if you wanted 2 solutions, then it would be a greater than. If you wanted 1 solution, it would be a less. And just for the record, you wouldn't end up with this crazy situation. If it was 2 solutions or 1 solution, you'd end up with a linear equation. Because you don't know how to do quadratics like that yet. It gets a little bit messy. Need inequalities that way. But in calculus, you learn about that. Yay. Okay. Last one. And everybody's favorite one. We did this. You saw a bunch of them where there was some sort of shape and they wanted to increase it. Okay? Sometimes it was a garden, sometimes it was a playground, sometimes it was just fences around a barn. And they give you a variety of shapes. And they always gave you like a rectangle, or maybe there's 2 boxes in it or something. In this case, if you read the question, it says a garden measuring 12 by 16 is to have a pedestrian pathway installed all around it, increasing the total area to 285 square meters. What will be the width of the pathway? So they even drew a nice picture for you. That's kind of them. You have your garden right here. It's 12 by 16. You then have this pathway around the outside. So that's this big box right here. If we were to look at the side lengths of that big box, I know that the bottom distance was 12. Right? That was the width of the old thing. It was 12. And then they increased it. How much did they increase it by? X is what most people would put. But they didn't increase it by X this time. They increased it by 2X because they added a pathway on each side. Right? They increased it by X this way, and they increased it by X that way. So the new width is 12 plus 2X. Because they added to both sides. The length of the garden is the same idea. There was 16, and then they increased it. But they increased it on both sides. So if they increased it on both sides, it's plus 2x. That's where the picture really helps on this one, is seeing that it's both sides got an increase. And I told you guys, even when we were doing these practice problems in class and stuff, that you're always going to get some sort of new trick or some sort of new variety. And it's always going to be changing. So it's important that you're learning the skill of looking at a question, analyzing what's happening, and then creating your own formula that makes sense. Like, that's the skill that's really being tested here. Can you take something and create a mathematical formula from it? You might remember we did the question with, like, the big barn. And then you had a fence, but it got broken into 2. Right? Like, this question is something that you actually had done in your practice booklet if you did your practice booklet. So it was usually pretty telling to see who got it right in their practice booklet and who just copied it. Because the people who actually did it in their practice booklet either got it or got close to it. The people who just copied down things, not so well. And so it became pretty obvious who was doing their practice booklet. What you would do, and also it's a really hard question. So if you didn't get it, that would make sense too. If you look at this, this one had 3 widths and 1 length. So your perimeter would have been 1L plus 3W. Right? So it's a question that you maybe hadn't been explained to you before, But the exact same skill of just being able to read a question and understand what's happening, that's what's being tested. And it's a hard skill to get. It comes from practicing doing a lot of questions. So one like this, same idea. You need to be able to look at a picture and understand what dimensions you're working with. Understand that this new box is 12 plus 2x. This new box is 16 plus 12x. If you read the question, they told you the area of the new place was 285. So that means if you did 16 plus 2x, which is length, times 12 plus 2x, which is the new width, it should give you your new area of 285. I would put money on if you can build that, there's a 90% chance you get it right from there. It's the building it that's going to be hard. If I want to figure what x equals, that means I need to solve for x, means I need to solve this quadratic. The answer cannot be solved right now because it's not equal to 0. So, what form do I have to be in to solve a quadratic? Got to be in general form. So I expand this thing to become 4x squared plus 24 plus 2 plus 56x plus 192 equals 285. And if I were you, I would just FOIL that or area diagram that to get that. So expand those two things, right? You get that. Promise. Then you need to move the 285 over. Get change colors, green for smiles. When you do that, you get 4x squared plus 56x minus 93 equals 0. There's a quadratic in general form. You can choose any method you want to solve it. If that's me, and I look at that question, I'm not going to try to factor it. It might factor beautifully. I don't know. It might not factor at all. So what I'm going to do is I'm going to solve this quadratic with one of my other methods. Box method is off. So then I'm going to do quad formula, or I'm going to graph it and find my x-intercepts. Either way works. Okay? Yep. It would be a good box question because it's even there already, and it actually would work out pretty decently. I just hate the box because I'm not good at it, right? Like I do what I'm good at. I'm good at factoring. I'm good at quad formula, and I'm good at graphing. I mean, if I'm good at 3 out of 4, like batting 75%, I'm in the Hall of Fame. So, like, I'm happy with that. I would graph it. Parsons is lazy, and I'm good with my calculator. So I go 4x squared plus 56x minus 93. I'm well aware that I'm going to struggle to see this in my standard window because I have negative 93 as my x-intercept, and it's facing upwards. So this graph's probably going to look pretty ridiculous. So I'm going to maybe do zoom fit, if you know what that is, or I'm just going to set a big window to start. If I'm talking about increases around my x's, I'm probably not going to have any x minimum. I'm going to have no more increase than 0, so I put x minimum 0. My x maximum, if I made that like 10 wider, that'd be a huge increase. So I'm going to put like 10, and that'd be way too big. Maybe put 5 or 6, if I'm more realistic. My y minimum, y maximum, that's my area to this question. That's what I'm looking for. Again, I would just probably put 2 really big y values, because I know my y minimum is going to be really low. But when it comes to setting windows for a random quadratic like this, like you're just going to have to do some guessing and some checking, or zoom fit, which is what a lot of you guys know, and zoom fit actually would work pretty good on this question because it doesn't really have context to it. I put negative 100 and 100, and it worked out perfectly. I go second trace. I find where my x-intercept is. And I get my x-intercept because it can be exactly. Yep. I get my x-intercept at 1.5. Now, if you did this question another way, so if you used factoring, which I'm guessing you can factor because that's a pretty nice number, if you use box method, if you use quad formula, you would actually get two solutions. You would get 1.5 and you would get negative something. Why would that negative something not work? You can't have negative increase, right? Negative increase wouldn't make sense for a pathway. So that's why we wouldn't have that negative answer included. It's why I also eliminated the negative side of my graph. Because you know you're not going to have a negative increase. So the width of the path all the way around would be 1.5. At the end of the day, these questions are about the setup more than anything. If you can set it up, I'm convinced you can solve it. Using one of your methods. You have 4 of them, right? 1.5. That's good. That's the answer. So what's the width of the pathway? Yeah, 1.5. That's it. Now they could spin that into a whole nother like ballpark of things, right? They could say, what's the width or what's the smaller side, right? And then you would say, well, the smaller side of my new garden or my new playground or whatever it is, garden, would be 1.5 times 2 plus 12. Then you'd actually have to calculate a new side. And so that's possible too. No, and much like that one's actually not bad, but you can guess and check it still, right?
I guessed the numbers and you can without even thinking.
Yeah, that's the thing. Like you've seen the test questions, like they're not questions you can guess usually. Some of them are, right? Like sometimes you got to guess a lot of times, but some of them aren't guessed. So all I have to do to make that question like a lot more challenging is change that to be 287. And now my answer is not going to be 1.5. It's going to be 1.678923, right? It's going to be an irrational. Or you just change it to say exact value, and then you're not going to know what that radical is unless you solve it using the quadratic formula. So like you can take questions like that, and it would be the same. Change one number, and now you understand like why you need to be able to solve it, not just guess. Because you're right, that one you could guess and check. 285. It's not that hard. Okay. That's Unit 1 and Unit 2.